Here is a number. 6 million tons. That is the rough mass of a large pyramid, like Khafra's. Now, divide that by 26 years. This is the length of time Khafre was said to rule. You get about 230,000 tons per year. This is not a guess. It is simple arithmetic. It gives us a starting point for a very big question. How did they do it? The number is so large that it is hard to picture. It is more than just a big pile of rock. It represents a massive, organized effort that lasted for decades. This single calculation forces us to look closely at every theory. 230,000 tons per year becomes about 630 tons per day. That's if work went on every single day for 26 years. No holidays, no weekends, no stops for floods, no stops for festivals. That daily number assumes constant quarrying, shaping, moving, and placing. It's the kind of number that makes you pause, like moving more than 300 large cars into place each day. First, we must look at the facts of time and scale. Khafra ruled for about 26 years, roughly 2,558 to 2,532 BC. His pyramid stands today at about 136 meters, originally about 143.5. The total stone is often estimated around 6 million tons. If the whole build took 20 to 26 years, the daily work rate is enormous. To place 630 tons per day, you'd quarry, transport, and fit hundreds of multi-ton blocks, day after day, year after year, with remarkable precision and coordination. The daily number makes many people stop and think. It pushes the limits of what seems possible with ancient tools. Some argue it's achievable with huge labor forces and the Old Kingdom's organizational power. Others note seasonal limits, quarries, site access, and the flood. Food, tools, and resources would be stretched. If work was seasonal, active days needed far more than 630 tons. The math stands, so maybe our method's picture is incomplete. New research changes how we see the pyramid landscape. We pictured Giza far from the Nile, making transport harder. But studies found a long, now dry Nile branch, the Aramat branch. It once flowed much closer to pyramid sites, about 64 kilometers near 31 pyramids. A wide, navigable river changes everything about heavy transport. Boats could bring blocks from quarries to the pyramid's doorstep, far more efficient than long overland drags. It explains why so many pyramids align along a line, not in the middle of nowhere, on a waterfront. Causeways likely led down to Aramat's banks, functioning as docks to unload massive stones, then staging for the final journey uphill. River and causeways formed an integrated transport system. It doesn't solve quarrying or lifting, just long-distance hauling. It cuts desert drag labor significantly. Smart engineering, tuned to the landscape, makes logistics plausible. Less fantasy, more practical reality. Beyond the river, on-site methods matter. The classic image shows thousands hauling stones up earthen ramps. A 2024 study suggests a more sophisticated technique. Clever hydraulic lift systems. Using satellite imagery and archaeological reports, they found signs of advanced water management aiding construction. Channels, gates, possibly even locks. Water directed into chambers beneath massive blocks, using buoyancy and pressure to help lift. Not replacing labor, multiplying its power. Guiding a force of nature beats sheer muscle. It fits their mastery of Nile water systems. Evidence near Djoser points to candidate water lift components. Finding similar evidence at Giza is the next step. Lifting millions of tons remains incredible, just smarter. River transport plus water-powered lifts is a powerful model. We may be underestimating their ingenuity. It helps close the gap between shocking math and known tools. Popular stories once claimed slaves built the pyramids. Modern archaeology says otherwise. A large workers' village shows a state-supported labor force. They ate meat-rich diets, cattle, sheep, goats, and had industrial bread making. Evidence of medical care and proper graves shows they were valued. The village was highly organized, supporting thousands. Feeding them required herds on a vast grazing area, about 465 square miles. Inscriptions inside Khufu name rotating work gangs. Recent finds confirm it. Red ochre marks record crews like the Friends of Khufu and tallies of days. Paid, organized, seasonal crews, often farmers during inundation. A sophisticated state mobilized labor for decades. Not slaves under the whip, but Egyptians on a national project. A monument to administration and logistics. Systems scaled to human needs. Real people, real organization, real capability. Yet, the math still prods us to keep asking how it all fit together, especially when we look inside. Better tech lets us see inside. Non-invasive tools, muography, and ground-penetrating radar reveal hidden cavities and chambers. In Menkori, scans found air-filled anomalies, suggesting a possible second entrance and hidden passages. In 2023, a hidden corridor was confirmed in Khufu. These weren't simple triangles. They planned intricate internal structures and stress features. Precision stonework under a 6 million ton load is mind-boggling. Hidden spaces invite multiple interpretations. Why were they sealed? What was their function? Part of the blueprint, or later changes? Hidden chambers don't prove building from scratch, or inheritance. They simply add complexity and show our knowledge is incomplete. Each new space forces us to adjust models. A humble reminder, these monuments haven't given up all their secrets. And that mystery keeps the investigation honest. We keep looking, measuring, and testing. So where does this leave us? We have two main ways to look at the pyramids. One view, Egyptians built them, step by step, using administrative might, a nearby river, and possibly water-powered techniques. Evidence supports scale, crews, and logistics. A story of epic human achievement. The other view starts with the shocking math. Could some big stones or core structures have already been there? In this view, Khafra's builders repaired, added, and encased older monuments. The daily tonnage makes the question worth asking. It's an alternative hypothesis, not a claim. Today, GPR finds hidden spaces. Satellites reveal lost rivers. Food remains show workforce scale. Inscriptions name crews. Each find fills a gap and adds a question. The truth may be a mix, built in parts, maintaining or repurposing others. Good science keeps questions open. The math, the river, the lift theory, worker records, and hidden rooms urge new questions. This is how we learn. Keep the numbers in mind. Keep the new finds in mind. Let questions, not assumptions, lead the search.